Yang penting kan upload tahunya dikerjain kan yuk. Ya. Video itu yang penting dikerjain kan.
Assalamualaikum warahmatullahi wabarakatuh. Today, my name is Rifqy Ergiano with name 123490015, and now I will demonstrate a web server ESP32 or REST API for application web and IoT. At the first, the objective is student understand the concept of web server on ESP32 microcontrollers. The second, students can create a simple REST API on ESP32. And the third, student can connect ESP32 with client application, browser, or IoT monitoring application. The fourth, students are able to test HTTP, request, response, get and post communication. And number two, theoretical basis. A. IoT and web server. IoT or Internet of Things is a concept in which physical device, sensor or actuators are connect to the internet and can exchange data with each other. The next is web server. On ESP32 allows device to act as data service providers that can be accessed via the HTTP protocol. The B, REST API, representational state transfer. REST API is an HTTP-based communication architecture commonly used in IoT. The main method is GET to retrieve data from ESP32 and POST send data to ESP32, put or patch to update data, delete to delete the data. The example is this code. This code is to client request temperature data from ESP32, and then this example is with play load status on, client turn on the light, the LED on the ESP32. 3. Tools and the material. The first is ESP32 dev kit, and then the next is cable USB, and then LED or resistor. The next is breadboard or jumper. The next is sensor DAT11 or DAT22. Laptop with Arduino IDE, and the last in the is the Wi-Fi access or hotspot or router. 4. Praktikum step. Here is the preparation. The first step is preparation. Install Arduino, connect the ESP32 to the laptop, and make sure the following libraries are installed, including the Wi-Fi, web server, and Arduino JSON. This is optional, but we use this. B. To make REST API in ESP32, the simple code is here. Right here, the library is include right the step preparation, web server, and Wi-Fi. The code, okay, and then 5 testing. Testing with a browser get request. This we use the Postman application. If successful, a JSON response will appear like here. LED off or LED on. The second is test with Postman. First, check status LED get. Here, like this. We insert the URL that we get from the Arduino. Click send, and the result will be display the JSON status of the LED. B. Change LED pause. LED status to the pause. Select pause. Select tab body raw and choose the JSON. Enter one of the data, LED on or LED off, and then click send like here. Okay, now we just go to the demonstrate from the Arduino and Postman. Now, here is the code at the Arduino IDE. This program is written for ESP32 microcontroller to create a simple REST API server over Wi-Fi that allows to controlling and monitoring the built-in LED. The first DSP connect to Wi-Fi network using the provide SSID and password. Now this is SSID. The password include this Wi-Fi connect. Then once connect, it initial web server on port 80 with three endpoint. The root endpoint respond with a plain text message indicating the API is running. The LED endpoint will get request return the current LED state in JSON format, either on or off. The same LED endpoint with pause request accept a plain body containing on or off with update the LED state and sends back confirmation respond in JSON. Internally, the LED is controlled by setting GPIO to high or low depending on the request state. In the main loop, the server continuously listens for client's requests and handles them accordingly. This code demonstrates how the ESP32 can be used as a Wi-Fi enabled IoT device to control hardware remotely via REST API. And then the next step, we have to upload the program to SP-Dev32 module. It's compiling the sketch. Wait until the program upload. And then the next is wait a second. Okay, the program has been running. Wait, the program has been uploading. Okay, the program has been done uploading. We go to serial monitor. Just click the reset button here. This. Okay. We get the IP address here. Just copy the code. and then we go to the postman. Okay, here is the postman. First, we just change the data to post and then paste the IP address before here, this IP, the to postman. And then make sure the body is raw and use a JSON. Okay, this just add some LED. Send it to. Okay, the status is update here like this, and then change the post to get data. To get data here, and then send again. Okay, the LED is on for this body JSON. Okay, I think that is my video today. Thank you for watching. See you in the next video.